All right, here we go. Unit 4, Lesson 12, a review of two variable systems of equations. So, a system of equations is a collection of two or more equations where I'm going to ask for solutions to both of those equations. So, what values of x comma y make both of these equations true? Right? Because there is an unlimited number of xy pairs that make the top equation true, right? Any of these points along this red line would make that's actually, yeah, the top equation true. And then any number of points along the blue line, x comma y, would make the blue equation true. The bottom equation true, right? That's what a line is. It's just drawing all of the solutions. So the one that they share in common, red and blue make purple, this right here, which looks like it's negative 2 comma 8, that is what we mean when we say a solution to a system of equations. It is the x comma y pair, if there are two variables, that make both equations true at the same time. And if your equations have different slopes when you graph them as lines, then they will always have one solution. But we're going to be putting those blinders on and we're going to be learning some techniques to find these solutions in an analytical way, meaning using algebra without graphing them. So without using Desmos, without graphing them by hand, how we would find the solutions to these systems. And there's going to be two main methods. One of them is going to be the easier one, and one of them is going to be the harder one, depending on the situation. They will always both work, but usually one is easier than the other. The first is known as the substitution method. And the way the substitution method works is you want to take one of your equations, either one, and solve it for x or y. So you want to get it in the form x equals or y equals. And usually you just look for which one would be the easiest to do that with, right? So I'm going to label these so we can start talking about these. I've got equation A, I've got equation B, and what I'm going to do is I'm going to take equation B and I'm going to rewrite it by subtracting x from both sides. I'm going to call that equation C. Y is equal to 6 minus x, which is still a true statement. If x plus y is 6, then y is 6 minus x. And the trick of substitution is that I can substitute the expression I found into the other equation. And so check this out. If y and 6 minus x are the same thing, which is what the bottom equation tells us, we can take 6 minus x and we can replace the y in the first equation with it. You'll see why that'll be useful in a second. We'll have 3x plus 2 parenthesis instead of y, right? I'm replacing the y with 6 minus x. That's what's happening to that y right there. And that's going to equal 10. And so the reason this is helpful is now I have an equation with one variable. Now we're just in Algebra 1, solve this equation land. First we distribute 3x plus 12 minus 2x is equal to 10. X plus 12 is equal to 10. And just like we found when we graphed this, the x variable must be negative 2 in our solution. Now we don't stop here, right? Because x equals negative 2, if I go back to the graphical interpretation, you've just found that the solution lies somewhere along this vertical line, x equals negative 2. But when we have a two variable system, we need both the x and the y pair. But this is just a matter of, this is the easy part. You take this x minus 2 and you just plug it back into either equation. I'm going to do the easy way here, so I'm just going to plug it into equation B. Equation B is x plus y equals 6. So now it's going to be negative 2 plus y equals 6, or y equals 8 when we add the 2 to both sides. So what we have here as a solution is negative 2 comma 8. Again, that's called the substitution method because you solve for one of the variables and you substitute back into the other equation to get an equation with just a single variable to solve for. Now, There is another method that will often be a lot faster, particularly if you have coefficients, meaning like the numbers in front of the variables on all of your variables. So let's see how we would solve. We know the answer is negative 2 comma 8, right? But let me show you a trick here in how to solve this. The elimination method. The way this is going to work is we are going to add entire sides of equations to each other. In order to be able to do that, right, the first step is to rewrite each equation so that the variables are lined up. And what I mean by that is that you have the x's, the y's, and the numbers, or whatever combination you may have. They don't have to be in this order, but you will often find them and you will often know, oh, the easiest way to do this is elimination if it's in the form ax plus by equals c, where a and b are the coefficients. And so again, for clarity's sake, I'm going to call this equation A, and I'm going to call this equation B. Step 2 says add the two equations together. Well, if I add them together, right, if I add them together, I'll do a quick demo here, right? If I add x plus y to 3x plus 2y, I have 4x plus 3y. And if I add 6 to 10, I'd have 16. Well, that doesn't really help, so that can't be what we're going to do. But I want you to understand, before we dive into it, the why we're allowed to do this. If I add x plus y to the left-hand side of A, and if I add 6 to the right-hand side of A, again, remember the whole concept of algebra is this concept of a scale. Well, x plus y and 6 are the same thing. The bottom equation tells us that. So if we added them to both sides of an equation, it's still a true statement. And that process is going to apply, but we're going to need to apply a quick trick first here, or a multiple of the two equations. So we want something that is going to line up such that it can be canceled. And so I'm going to make this next equation, I'm going to call it 2b, meaning I'm going to multiply everything in b by 2. So we're going to have 2x plus 2y, and sometimes I like to put a little circle around this, equals 12. And so the trick here is that now, and you can either add or subtract, if I do a minus 2b, the two y's will cancel. So if I do a minus 2b, I'm going to have 3x minus 2x. 3x minus 2x will give me x. 2y minus 2y will cancel. And 10 minus 12, there it is, x will be equal to negative 2. And sorry, I was supposed to do that down here. We'll have a minus 2b, x equals negative 2. And so that's it. And so that would be a lot faster than the substitution method. Now we would still have to go back and we'd have to do, okay, we'd have to do if x plus y equals 6, then negative 2 plus y equals 6, and y equals 8. So the same process would apply to finishing it out. The finishing process is always the same. Once you have all but one of the variables solved for, you can take it back and plug it in to solve for the other variable. Now, the last thing I want to leave you with is just an example of when elimination is easier versus when substitution is easier. Substitution is typically easier if you have already solved for a variable. So in this case, we already know that x is equal to, in this system of equations, 2y plus 3. So the fact that it's equal to x means I can take 2y plus 3 and plug it in for x in the second equation. And so we'd have 2y minus 4 parenthesis 2y plus 3 is equal to 6, right? Substitution, all I've done is replace the x with 2y plus 3. Now we will distribute the negative 4. 2y minus 8y minus 12 is equal to 6. And it's just a little algebra from here. Negative 6y minus 12 is equal to 6. Negative 6y is equal to 18. And we'd have y is equal to negative 3. So, that's the hard part. You don't want to forget, right? You're not done. You do have to take this negative 3. You can plug it into either equation. It's going to be easier to plug it in to that first equation. And so we'll have x is equal to 2 times negative 3 plus 3. Oh, look at that. X equals -6 plus 3. X is also equal to -3. So your final solution here that you would box up is -3 comma 3. That is an example of substitution being easier for two reasons. Number one, X was already solved for. Number two, none of these variables are really lined up. Okay. Versus if we look on the right side equation, the variables are already lined up. The variables are on top of each other. The x's are on top of each other. The y's are on top of each other, and the numbers are on top of each other. The only issue here, I just wanted to give you a difficult one here to finish this off. The only issue here is that equation A and equation B don't quite share any coefficients in common. So we're not ready to add or subtract them. But what I can do is I can make a new set of equations so that they do line up. And the way you want to do that is you want to think about what can I multiply A and B by to make things line up. And there are an infinite number of options. One thing you could do is you could do 5A and 3B. That way you would have 15x and 15x. Another method you could do 6A and 6B, and 4B. If you did that, you'd have 24y on the top and negative 24y on the bottom, and you could add them. But I'm really lazy. I want to do the least amount of multiplication I can, so what I see is that 4y and 6y can both be made into 12. If I do 3a, which is going to be 9x plus 12y equals negative 39, right? Everything's multiplied by 3. And then I'm going to do 2b. That's going to be 10x minus 12y is equal to 60 minus 2, 58. And now I have these opposite coefficient here. So in the first example, right, going back to this, I subtracted. I did a minus 2b so that this 2y and this 2y canceled. Now I'm going to add these things together. 3a plus 2b. 3a plus 2b. And again, you can keep track of your work like that. Well, if we add these things together, we'll have 19x. The 12y's will cancel out. And we'll have negative 39 plus 58. Didn't make the mental math easy on us here. Oh, that's just 19. That's nice. Negative 39 plus 58 is 19. So we'd have x is equal to 1. Again, the last step would be to go back, take this x equals 1. I want to plug it into that first equation. 3 times 1 plus 4y equals negative 13. 4y is equal to negative 16, and y is equal to negative 4. So the solution here would be 1 comma negative 4. And so that's the elimination and the substitution methods from Algebra 1.